So let's check this problem here. We have a W-shaped member with yield strength of 36 KSI and the ultimate strength of 58 KSI. And this member, it carries an axial live tensile load of 420 kips. The member's flanges are bolted on a connection bracket, and we know that the shear lag factor equals 0.9 for this connection. We want to calculate the required net area based on the fracture criteria. So we know that we need to calculate the net area only for the fracture for this problem. So we will start by the fracture strength criteria equation that we know, which is phi Tn equals phi F ultimate AE, which is the area effective. We know that phi equals 0.75 for the shear failure, and at the same time we know that the area effective equals U multiplied by area net, where U is the shear lag factor, and we know that the shear lag factor equals 0.9, which is given here in this problem. So this means that the area effective equals 0.9 area net. After that, we can calculate the phi Tn, which will equal 0.75 multiplied by 58, which is the F ultimate. You need to take care that here we use the F ultimate, not the F yield. So we will use the 58 multiplied by 0.9 area net. But what does phi Tn equals? We know here that it is given the load, which is 420 kips. But you need to take care that this is an axial live tensile load. This is not the ultimate load, which means that you need to calculate the ultimate load based on this live load, which is going to equal 1.6 multiplied by 420. So this means that 1.6 multiplied by 420 equals 0.75 multiplied by 58 multiplied by 0.9 area net. The only unknown here is the area net, which could be calculated based on this equation to equal 17.1 inches square. So the answer is the second option, which is 17 inches square. So this is it for our video today. See you in our next video. Thank you.